folk. Suhani, you feel you're a betting person? Great. What do you say is the surface area to the first one? Because I don't know it exactly, but I will know it when I hear it. 10,460. That is exactly right. 10,460. I don't care what your exact number is. If it's close to that, I'm happy. How many people need to see why? Okay. So, I wrote it out here to show you how to do it. The prism is 50 by 40 plus 40 by 30 plus 50 by 30, which is 9,700. Then you cut out those two circles because there's holes in it. So you subtracted 2 pi 7.5 squared because that's the radius. Then you added 2 pi 7.5 times 30 because that yellow is new surface. So you had 9,700 plus 15 times 30, 450 pi, 9,700 plus 450 pi minus 7.5 squared is like 56 times 2, 112, minus 112 something pi. So you had 9,700 minus 338 pi approximately. And then add plus 338 pi, which is close to about 1,200. Everybody good? I can show you the exact numbers if you need them, but again, it doesn't matter.
I think it's 94.
Oh yeah, it's 9,400. Thank you. It's 94. Okay. Excellent. Who would like to give me the volume? Suhani, you already had a chance. Jasleen.
Okay, I don't think this is right.
Then why would you risk putting your hand up?
Because you got to risk.
You do. I'm actually glad you are, because I have had many classes that no one has put their hand up to this question. What is 3 minus 3? I have had classes sit there in silence because they think I am tricking them. Even when I write 3 minus 3, dead silence. I have had guesses of that. Now, I have also had guesses. What is 1 times 6x squared? Dead silence. 6x squared. I'm not fooling anyone. Now, Jasleen, go.
54,000.
Yes, exactly right. Don't care what your number is. Does anybody need to see why? Okay. Okay. What is the volume of that shape? Area of the base times the height. So 50 by 40 by 30, yes? 60,000. Then I cut a hole in it. That hole is this big. So that volume is being removed from 60,000. The volume of a cylinder is pi 7.5 squared times 30. Okay? Who would like to tell me the surface area of this cone structure I have drawn here? Preston. 201 pi. For its surface area, 201 pi. Which I think sounds right. Or, of course, you have something around 665 or something. Yeah, whatever. It's 631 is close to 600. I'm doing it in my head. All right, so let's talk. Manraz, what? You got that? Okay, let's talk. What is happening here? Preston. Yeah, it's been cut off. So, if none of this was here, I would have that cone, yes? And that cone, because I've drawn it in black, is pi r squared plus pi r slant, right? But then, I cut off the top of it, creating what? A circle. So I must add a pi r squared. Oh, wait, I'll change color. I must add a pi r squared, correct? But what was taken away? The top of the cone, which is, and I got to change color again, which is minus pi r slant. Because that's the pointy part of a cone. Now, how do you figure it out? Well, I need a slant on the big cone. The big cone is black. How do I find that slant? Same way I find slant always. What is it? Pythagoras. 9 and 12. Which, we remember 3, 4, 5 triangles. 9 is 3 times 4, right? Or 3 times 3. 12 is 4 times 3. So a 3, 4, 5 triangle times 3 means this is what? 15. So pi times 9 squared plus pi times 9 times 15 plus, in red, pi r squared, pi times 3 squared minus pi times 3. What's the slant? 3, 4, 5. 81 pi plus 9 times 15, 135 pi plus 9 pi minus 15 pi. 135 minus 15 is 81 plus 9 is 90 plus 135 minus 15 is 120 pi, which is 210 pi. Everybody good? Why wouldn't it be not? 210 times 3.14. So about 660. Great. That's fine. Again, do the work. I'm happy. Any questions? Now, listen to me. Is the math difficult? No. This is the difficult part. So let me suggest, before you build a snowman, what must you do? Have snow. Then what? You got to get your carrot and nobody has coal anymore. I personally use dog kibble. Because then when the snow melts, some animal can eat the dog kibble. You get your materials together. Then what? You roll 3 snowballs, and then you put them together, yes? Oh, wait. First, dad joke. Math. Have a plan first. Why did I write? Why did the school district buy these pieces of garbage? Why did I write that? That's my plan. That's what's happening. Then I do my formulas. Volume. What's volume? Who has an answer for me? Hit me, Ashni. 312 pi. Do we have corroboration? 398 pi. 398. 390. Okay. Preston. No.
I got 320.
1,000 and something is close to the actual answer, not with a pi. So, of course, you have a plan first. It is the volume of a large cone minus the volume of a small cone. The large cone is the same as everything. Pi r squared h over 3 minus pi r squared h over 3. Since they're the same denominator, you can put it all over 3, and you do pi times 9 squared times 12 minus pi times 3 squared times 4, which is, of course, 81 times 12 is 810 plus 92 is 902 pi minus 9 times 4 is 36 minus 36 pi is 868 pi divided by 3, which is 3 goes into 8 twice, 26 goes into that 8 times, leaving me with 28, which is 9, 289 and a bit pi. What? Is it 972? Okay. So 972 minus 36 pi is 936 pi, which is 3 goes into 9 thrice, once, 2 pi. 312 times 3 pi will give you the number, which is going to be around 1,000. Questions? $40 times 50 is 2,000. 2,000 times 3 is 6,000. Add a 0, 60,000. Well, did you subtract the right area? Did you do 7.5 squared times 30 times pi? Well then, you didn't do the right area. The following cylinder is cut in half. Surface area first. Have a plan. It's a cylinder divided by 2, because it's cut in half, plus what did I just make? Plus a rectangle. Fill in your plan. 2 pi r squared plus 2 pi r h over 2 plus LW. What happens to all those 2's?
Cross them out.
They cancel. Pi r squared plus pi r h plus LW. Pi times 8 squared plus pi times 8. What's h? 12. Even though the cylinder is lying down, the height still goes from base away. Plus 16 by 12, which is 64 and 96, 160 pi plus 192. 192 plus 160 pi, which is going to be somewhere around 400, 500, somewhere around 692 pi. Or no, sorry, 692 total. Of course you have to do 192 plus 160, because when you cut it in half, you created a new surface. Okay, there's no way for me to teach you guys how to see, right? You have to have a plan. You have to understand what is actually happening. Okay? We talked to death about what surface area is. It's the exposed surfaces. So if you have a block of cheese and you cut it in half, you get 2 new surfaces. right? And then volume, of course, is just pi r squared h divided by 2, which is pi times 8 squared times 12 divided by 2, which is 64 times 12 pi over 2, which is 640, and 128 is 728 divided by 2 is 350, 364 pi. Again, I'm working out of my head. If you did this, you have the right answer, because the radius is 8 squared, the height is 12, and it's been cut in half, so you divide by 2. Explain to me, no, I lie, because if I say explain to me, 30 of you will start talking. Explain to yourself, in your head, self, why do I have to add for surface area, but not for volume? Everybody think about it for a moment. Get it in your brains with the words you would use to explain that to yourself. Because I have explained it a million times and people still aren't getting it. So you decide how you need to word that sentence so it works for you. Take a moment and do it while I while I set up the next question. Yes, Jasleen. Okay. Is this a cylinder? Pretend there's no hole. Describe to me the surface area. Everything on the outside, because there's no hole, yes? What is that? Excellent. What is that? You know it's a rectangle, right? What is that? Excellent. So the surface area is pi r squared plus the second pi r squared plus this rectangle, which is 2 pi r for the width times the height. Yes? Agreed? Okay, now, cut it in half. The surface area is everything on the outside, yes? Is there anything in the middle right now? No. Once I cut it in half, is there something in the middle? Is that a new surface? So do I need to add a rectangle? Because the surface area of this is only the brown that you see. You do not see any brown in the middle until I cut it open. When I cut it open, this is all gone, so this surface area has been cut in half. I've lost half that circle, and half the rectangle. But I have gained this rectangle. That's for volume. Has everybody understood in their own brains what Jasleen just asked? Why am I adding for surface area even though I am removing part of the shape? Because I am creating a new surface. Okay? I do not create any new volume. Hemisphere. Hemisphere, first question, is it solid or not? Do you know? Yeah. I didn't specifically say. So some of you might have done 4 pi r squared because the inside and the outside are the same, aren't they? Hopefully you recognize I obviously meant a solid hemisphere and you did 3 pi r squared for the surface area. Why is it 3? Because it's 4 pi r squared for the outside divided by 2, but then I got a new circle. So that is 3 pi 18 squared, which is 3 pi times 324, which is 972 pi, which is somewhere around 3,000. That's a low 5. She wanted a high 5. Up top. There you go. volume is 2 pi r cubed divided by 3 because it's a hemisphere. So that is 2 pi times 18 cubed divided by 3. I cannot do 18 cubed in my head. 5,832 times 2 is 10,000, 11,600, 11,664. 11,664 divided by 3. 11,664 divided by 3 is 3888. 3,888 pi, which is going to be somewhere in the neighborhood of 12,000. Everybody good? Excellent. And last question that I asked you to do, because it's almost lunchtime. A grain silo is composed of a hemisphere on top of a cylinder. When you draw this, it's going to look naughty. I am getting out in front of this now because as soon as I draw it, a bunch of the teenagers in the room are going to go and a bunch of people aren't because a bunch of people didn't draw it. So, what is the volume of this silo? So, since it's volume, it's just adding, right? I have the volume of a cylinder plus the volume of a hemisphere. The volume of a cylinder is pi r squared h, plus the volume of a hemisphere, 2 pi r cubed over 3. Fill in the numbers. What's the r? R is 3 squared. What's the h? This is tricky. Yes. Oh, not plus. I forgot the 9. 9. Because that's the height, pi r squared h, plus 2 pi, what's the r of the sphere? 3 cubed divided by 3, which is 27 times 9, which is 180, and 63 is 243 pi. No, what am I doing? It's 81 pi plus 3 cubed is 27 times 2 is 54 pi. 54 divided by 3 is 18 pi, which is 101.99 pies. Right? Right. This question I used to put on a test. I had to stop putting it on a test. Who can tell me why? No, it's not too hard. It's 2 shapes. No. Of course I can. There's a cylinder on the ground, and then it goes up, and then there's a hemisphere up there, and there's a door right there, and there's usually a door up here, because often you dump the grain in from the top. I know it doesn't look bad. It looks like a silo. That's okay. You don't need to get it. Now, listen please. Nobody gave me the answer. Why did I have to take this off? Because don't you tell me that math is difficult. It's a volume of a shape you know plus a volume of a shape you know. Why did I have to take that off tests? No. No? Pardon me? Damn right it's life related. We live in a farming community. Silos all over the place here. Why did I have to take it off? No. Because you didn't need to draw it. I didn't need to draw it. Why did I have to take it off? No. What was that, Selena? If you don't know what a grain silo is, you could say you couldn't do this question. Even though I actually describe what a grain silo is. Kids were still saying, I can't do it. I don't know what it looks like. Read the question to me. It's a hemisphere on top of a cylinder. I don't know what it looks like. What's a cylinder? Oh, it's like a toilet paper roll. Excellent. What's a hemisphere? Like half a ball. Where would the hemisphere be? On top. What's it look like? I can't do it. Pre-diploma kids couldn't do it. So now I put it on here so I can tell this story. I know, right?